Welcome to another episode of Tech Unpacked, where we dive into the fascinating world of innovation and technology. I'm your host, and today we're talking about a groundbreaking development in the realm of artificial intelligence, specifically a new model known as Kimi-k1.5. So buckle up as we explore how this model is pushing the envelope in multimodal learning and reinforcement learning. To kick things off, let's talk about what makes Kimi-k1.5 stand out. This isn't just an update, it's a significant leap forward. Imagine you're training a dog with treats. Traditionally, you give rewards based on specific actions. But what if you could teach that dog to explore its environment, discovering new tricks and skills through rewards? That's essentially what Kimi-k1.5 does with large language models, or LLMs. It scales reinforcement learning to unlock new educational potentials through exploration and reward. So what exactly are the key ingredients that make Kimi-k1.5 so powerful? Well, first up is something called long context scaling. Think of it like expanding the boundaries of a classroom. The model's context window has been scaled to an incredible 128,000 tokens. The fascinating thing here is that performance improves as the context length increases. It's as if you can hand a student an entire library of information to browse at once instead of just one book. Who wouldn't do better with that? And here's where it gets clever. Kimi employs a strategy called partial rollouts. Imagine a chef who preps a big meal but doesn't start from scratch every time. Instead, they reuse some parts of their previous meals. This not only saves time but also enhances efficiency in cooking. In the same way, Kimi utilizes previous data to sample new trajectories, which enhances its learning process without the computational costs of starting over. Now let's dive into the improved policy optimization aspect. This model utilizes something called online mirror descent. It might sound complex, but think of it like a nimble dancer learning to refine their movements over repeated performances. The optimizations incorporate clever sampling strategies and even a length penalty, dedicating more attention and refining techniques as the dance or training progresses. Of course, we can't overlook the beauty of its multimodal capabilities. Kimi-k1.5 is not just a text-heavy tool. It can reason over both text and visual data. Imagine solving a problem that requires both reading a recipe and watching a cooking video. That's the kind of synergy Kimi is creating, reasoning across different data types to enhance understanding and decision-making. Now, for those who are curious to see it in action, Kimi-k1.5 can be tested via the Kimi Open platform. You fill out a form, and you get to interact with this state-of-the-art model. If you've got a mathematical question, like finding the hypotenuse of a triangle based on its legs, Kimi could provide the answer immediately, all through a simple API call. Okay, let's pause for a moment here. If you're wondering how Kimi stacks up against competitors, the numbers speak volumes. Kimi-k1.5 has recorded jaw-dropping performance metrics at benchmarks, 77.5 on AIME and a striking 96.2 on Math 500, surpassing established models like GPT-4o and Claude Sonnet 3.5 by hefty margins. So to wrap up today's discussion, we unravel the layers of Kimi-k1.5. Its long context scaling that works like a vast classroom, the efficiency of using partial rollouts, the refined policy optimization akin to a skilled dancer, and its unique multimodal learning capability. It truly signals a thrilling advance in how we perceive and engage with AI. As we close this episode, I leave you with a thought-provoking question. What could the future hold as we continue to enhance our AI models through techniques like reinforcement learning? Can we imagine a world where AIs